Hello everyone. I am delighted to provide you with an introduction to Holtek's high-efficiency BLDC motor control MCU solutions. I will first introduce the motor development and market overview, then the HT32 BLDC motor MCUs and platform, followed by Holtek's Advantageous techniques and solution features of motor control. Common motors include DC brushed motors and AC induction motors. DC brushed motors are driven by commutation with carbon brushes, and the drive mode is simple. However, there are problems such as service life, noise, and heat dissipation. AC induction motors are usually very inefficient at a power of 1 kilowatt or less, resulting in a higher temperature rise. Brushless DC motors improve the disadvantages of DC brushed motors and AC induction motors, with the characteristics of long service life, high efficiency, low speed and large torque, low noise, and high control linearity. Many products such as air conditioners, compressors, floor fans, air purifiers, ceiling fans, and electric vehicles are actively introducing BLDC motors instead of DC brushed motors or AC induction motors. Therefore, the global motor market will continue to grow, with a compound annual growth rate of 5.7%, and is expected to reach $22.3 billion by 2025. Among them, the global distribution accounts for 37% in Asia-Pacific, 28% in Europe, and 26% in Americas. The world is making efforts to protect the environment to achieve a vision of zero carbon by reducing its carbon footprint. In order to promote the life of the next generation and the sustainable development of mankind, from energy conservation to switching to green energy, the United Nations began to advocate the concept of ESG, environmental, social, and governance. Holtek has established an ESG Sustainable Development Committee to promote the sustainable development mainly from the following aspects. 1. Development of BLDC and other green-related MCUs. 2. Holding Holtek Cup competitions to promote the cultivation of talents in the electronics and information industry. 3. And assessment of the company's operational risks. BLDC motors are characterized by simple structure and high efficiency. In the future, miniaturized PCBs will be more needed in motor modules, so the integration of ICs will become higher and higher. For example, MCUs will have an integrated gate driver or driver. Benefiting from the advancement of motor efficiency and lithium battery technology, there will be more and more handheld lithium battery products, such as wireless vacuum cleaners and hair dryers, which have become a must-have in the families. After the electrification of garden tools, we smell phytoncide instead of gasoline when mowing grass. In addition, in the modern era where the Internet of Things is getting more and more attention, there are more and more relevant products that support motor speed remote adjustment, and MCUs are often used as a motor drive and peripheral control. All these successes depend on advances in motor control technology. In the future, FOC high efficiency or the convenience of sensorless drives will be the major BLDC motor drive solutions. Holtek's vision for BLDC motor products is to provide complete chip solutions, including MCUs and integrated system-on-chip MCUs, as well as more advantageous algorithms and high-quality services. Presently, Holtek has made great achievements in the BLDC motor industry, which can be divided into the following major projects: fans, personal care, kitchen appliances, handheld tools, industrial control, and electric vehicles. Each project has a list of related products for your reference. Now let me introduce the Holtek's HT32 BLDC motor MCUs. Holtek's BLDC MCUs were mainly 8-bit MCUs before 2020, and after 7 years, we have accumulated a wealth of motor control techniques and experience, which has laid a solid foundation for us. In 2020, Holtek released its first 32-bit ARM M0 Plus motor control MCU, which is specialized in 2-shunt FOC algorithm. In 2021, a 1-shunt FOC dedicated 32-bit MCU was released. The interior design of these MCUs are planned and designed through our accumulated knowledge. Additionally, the second generation of 8-bit products and system-on-chip MCUs with a gate driver or driver have been released in 2022. In terms of 32-bit products, hardware-assisted computing and CAN bus will be introduced in the future, and the application of products will become more and more extensive. Holtek's BLDC MCUs can be distinguished by the drive technique and rotor positioning method. The 8-bit MCUs focus on the square wave Hall, sine wave Hall, and square wave sensorless drive techniques, while the 32-bit MCUs focus on FOC control or square wave sensorless products which require a complex human-machine interface. In order to meet the requirements of miniaturization of the drive circuit, Holtek has released MCUs that include an LDO and gate driver. Considering the thermal problem, packages with a thermal pad are used, and a series of system-on-chip MCUs with a gate driver and LDO will be released successively. Our system-on-chip MCUs with integrated gate driver have the following features. 1. A high-accuracy LDO. 2. 3 integrated bootstrap diodes. 3. Low standby current consumption and a variety of protection functions. The 18-volt and 48-volt types have been released, followed by the 36-volt and 110-volt types, while the 200-volt and 600-volt types are under design. In pursuit of a smaller PCBA, we have further integrated 6 MOSFETs that drive the BLDC motor. This is implemented by placing the entire BLDC driver circuit into one IC, achieving the most integrated all-in-one system-on-chip MCU solution. Our system-on-chip MCUs with integrated driver have the following features. 1. A high-accuracy LDO. 2. Charge pump architecture. 3. Integrated high-voltage FG signal. 4. Low power consumption and multiple protection functions. The 8-bit 15-volt and 1.5 amp type has been released, and the 32-volt and 4.5 amp system-on-chip MCU type is expected to be available in April 2023. The HT32F65X40 series includes the pure MCU type, gate driver type and driver type, which are specially designed for 2-shunt FOC solutions. Real-time 2-shunt current sampling is implemented using two 1 mega SPS AD converters and 2 operational amplifiers, combined with the AD converter's high-priority trigger and PWM arbitrary cycle trigger mechanisms. The speed command can be obtained by reading the VR command through the AD converter or by capturing the PWM command through the SCTM. The GPTM has special features designed for position sensors, which will be introduced in more detail later. The HT32F65X32 series of MCUs focus on 1-shunt FOC and square-wave sensorless algorithms, which uses a 2 mega SPS AD converter and asymmetric PWM signals to sample the bus current. Then the phase current information is reconstructed for FOC control. Therefore, only one current sensing resistor is required. This is a very cost-competitive algorithm. The GPTM is used to capture the rotor position sensor signals such as Hall sensor or encoder. In order to facilitate the acquisition of Hall sensor signals for rotor speed calculation, an XOR operation is established so that the speed information can be obtained as long as there is a change. Regarding the encoder, in addition to the angle information obtained by GPTM, the speed information can also be obtained through the velocity clock and SCTM. A phase error mechanism is also provided to prevent noise from causing hardware calculation errors. In order to make the square-wave sensorless commutation signal more accurate and stable in low-speed environments, a back EMF filter circuit is introduced. Traditionally, the PWM duty must be 100% to ensure a clean commutation signal, as shown in the green waveform. However, after turning on the back EMF filter, the green commutation signal is very clean at low speeds. This reduces the PCB layout burden and high-speed phase delay problems, increasing the startup stability. The HT32 full range of MCUs have passed the UL60730 MCU self-check certification, and the HT32F65X40 series has also passed the Motor UL software certification. With our UL software certification for motors, customers only need to pass the hardware UL certification, which can greatly reduce the time, money, and software engineering load of customers for passing UL certification, so that customers can concentrate on product development other than motors. Our high-efficiency HT32 BLDC motor workshop provides a very friendly software interface and complete hardware resources, with which customers can quickly start evaluating Holtek solutions and developing motor drive products. Now let us look at a presentation video of the 32-bit motor workshop. The HT32 BLDC Motor Workshop can assist users to quickly introduce the Holtek BLDC FOC solutions and accelerate the development processes. This workshop supports 2 shunt and 1 shunt FOC solutions, provides Hall and sensorless algorithms for user selection, and also provides speed control and torque control selections. Advanced functions include field weakening control, dead time compensation, speed and position estimator, etc., which can be individually turned on as required. Complete protection functions include Hall error protection, locked rotor protection, overcurrent protection, etc. After being triggered, the protection mechanism can be motor free running or motor brake. The hardware consists of a evaluation board and 3 power boards, which are a DC low voltage board, a DC medium voltage board, and an AC high voltage board. The power board is connected to the evaluation board, and the hardware communicates with the workshop through UART. The workshop also supports programming and online debug under the BLDC environment. A virtual oscilloscope is also provided, where users can observe the motor dynamic response and operational efficiency after selecting the relevant FOC operation parameters, greatly shortening the product debug time period. After this, the parameters can be exported for product secondary development. The above has provided the introduction of the HT32 BLDC Motor Workshop. There are Hall sensor and sensorless solutions based around FOC. The graphical interface consists of parameter adjustment, real-time control, and a virtual oscilloscope. The projects generated can be used for secondary development. The hardware is composed of an EV board and 3 power boards, which can meet the needs of most motor products. The BLDC Motor Workshop will guide the user step by step until the project is produced. Then the BLDC motor monitor can operate the motor in real time and monitor the motor operation efficiency and characteristics with a virtual oscilloscope. The final optimized parameters can be imported back into the project. This motor monitor software can also be used through the Motor UL software. Finally, customers can use KEL to start the project for secondary development. These are the parameter adjustment screens of our HT32 Motor Workshop, which will guide users to complete the systematic settings, including motor specifications, hardware settings, and software parameters. The HT32 BLDC motor monitor can give real-time commands to operate the motor, observe the motor operation status with a virtual oscilloscope, and adjust the parameters in real time to optimize the motor operation. Finally, export and save the parameter file to replace the original parameter file of the project. Another unique feature of this platform is remote adjustment. There is no need to set up the same site or equipment as customers, saving commuting time and improving real-time service. For example, when a 100-inch ceiling fan of the customer has problems and requires assistance, we can assist in the product adjustment through video and remote control. Regarding the algorithms, the HT32 Motor Workshop provides multiple choices, including 2 shunt FOC or 1 shunt FOC, speed control or torque control, and Hall sensor or sensorless. There are a lot of advantageous techniques, which will be introduced later. There are also other more advanced algorithms that are being developed. Our research and development, either in IC or algorithm, is constantly advancing. I would like to share it with you that some customers have fed back to us that after getting used to Holtek's motor workshop, they can complete the machine adjustment of a model in half a day. Next, I would like to introduce what are the benefits of Holtek's advantageous BLDC motor drive techniques. Since unevenness often occurs during Hall sensor placement or magnet charging, we provide a Hall sensor compensation strategy to ensure a smoother angle and a more sinusoidal current, and also reduce the vibrations and noise. Initial position detection, also known as IPD, is often used as a stable startup strategy for sensorless operation. Holtek's patented IPD technique is based on a FOC architecture, without requiring additional programs and hardware circuits. Our IPD technique results in reduced noise and basically no vibration. For FOC sensorless operation, we also provide a connection technique for switching from open loop to closed loop. There is no sudden change in angle at the connection point that will cause torque pulse, vibration, and noise. The automatic current PID gain is the optimized gain calculated according to the theory of motor and control parameters. This can greatly reduce the number of trial-and-error times and improve the efficiency of machine adjustment. We also provide multiple positioning startup strategies. The first is the adaptive positioning. Traditional methods use fixed-time positioning. However, our adaptive positioning will in real time determine whether the positioning has been completed, by which the positioning time is shortened, and the discomfort caused by mechanism and blade vibrations will also be reduced. Another startup strategy is adaptive startup, which has better load adaptability and does not require a high current for startup as traditional methods. For the same load and target speed, the adaptive startup method only needs a current of 0.4 amp to complete the startup. Such adaptive startup has the advantage of 100% startup. The purpose of flux weakening control is to operate the motor above the rated speed within a short time period. This is implemented by using the weakened magnetic field. During operation, pay attention to high temperatures to avoid motor demagnetization. Here is an example. After using the flux weakening control, the speed is increased from 2,700 revolutions per minute to 8,000 revolutions per minute, a 200% faster improvement. Such technique is commonly used in electric vehicles, compressors, washers, and other products. The overmodulation technique is also a method to increase the speed, which is implemented by increasing the utilization rate of the voltage. Generally, it is a sine wave during the linear zone, and from a vector point of view, there are voltage spaces, as shown in black, that cannot be used. By using the overmodulation technique, an effect as shown here can be achieved. When the modulation rate changes from small to large, the waveform changes from the original saddle wave to trapezoidal wave and then to square wave. At this time, the voltage utilization rate is at its highest. As can be seen from the waveforms, it is very smooth to enter or exit the overmodulation zone. Electric vehicles often require instantaneous and high torque startup. It is well known that square wave torque is greater than that of sine wave. Therefore, we also provide FOC loop-based square wave control, eliminating the need to establish complex programs and processes to switch between square wave and FOC. As can be seen from the waveforms, it is very smooth to switch from square wave into FOC, or back to square wave from FOC, and no normal current is generated. Many hairdryers, vacuum cleaners, and blowers that originally used square wave drive technique are now evaluating the FOC drive technique, mainly because the later results in less vibrations and noise. We also offer high-speed FOC solutions, where the two-pole motor speed can reach up to 150,000 revolutions per minute. Under the conditions that the low-voltage PN gate driver has a small driving force or the high-voltage IGBT architecture has a long dead time, the current continuity will be poor and the harmonic content will be increased. Deadband compensation can be used to improve this problem. The current waveform is obviously unsmooth when there is no deadband compensation, and becomes smooth when the deadband compensation is added, with reduced harmonic content. If the motor has not been driven but rotates by an external force, the drive control needs to intervene, which however will result in current surges. In response to this problem, we provide a voltage compensation strategy, and it is clear that the current surge problem has been improved. Some products have PCBA space limitations, which allows for a small DC bus capacitance value, resulting in large torque ripples at high speeds, which in turn leads to vibrations and noise. Based on the fluctuation of DC bus voltage, a voltage ripple compensation mechanism is introduced to improve the vibration and noise problem, and reduce the maximum motor phase current. Holtek's Motor UL software certification includes the MCU self-check, OTP, OCP, and OSP for items. If the customer's product UL software certification items include the above 4 items, then the customer only needs to pass the hardware UL certification. In addition, we will also provide a factory inspection platform to facilitate customers' subsequent mass production sampling inspection. This is our certification number. Since FOC-related control often requires motor parameters to control well, we have developed an automatic motor parameter recognition technology. Using Holtek's platform software and hardware environment, the motor parameters can be obtained in seconds, eliminating the time of manual measurement. The above are Holtek's Advantageous techniques, and more new techniques will continue to be introduced in the future. I believe that you have had a deeper understanding of Holtek's BLDC MCUs, platform and advantageous techniques, and now I will introduce how these advantageous techniques can be used in the BLDC solutions. BLDC ceiling fans can be divided into household use and industrial use. We used an HT32F65240 to implement 2-in-1 control of main control and motor drive. In addition to motor drive, RF reception and LED dimming are also realized. Holtek also has a complete range of RF transmission and reception ICs for your choice. This solution uses FOC sensorless speed control. Due to the large inertia of ceiling fan blades, it is easy to produce large vibrations during positioning, so the IPD startup strategy is usually used to avoid this problem. The forward and backward switching is smooth, and multiple protection mechanisms are also available. According to the final sales needs, you can choose whether the motor software UL certification mechanisms are required. Hairdryer products have gone through traditional universal motor models, DC brushed motor models, and now the BLDC motor models that are launched by various manufacturers. Our HT32F65231 shunt FOC control strategy is not only simple in the peripheral circuits, but also available in a 24 SSOP small package, which is very cost-effective. The speed can reach up to 130,000 revolutions per minute, covering the highest speed of BLDC hairdryers on the market. It adopts an advanced startup strategy, which has the advantages of fast, smooth, and noiseless. Due to the limited space of the hairdryer, the capacitance value is usually small, and the bus voltage ripple is large, so DC bus voltage compensation is required to reduce vibration and noise during operation. With various protection mechanisms and constant power control, product stability has been improved. This BLDC hairdryer solution also has an additional function of intelligent temperature control to avoid scalp burns, and backward rotation to clean filter. This BLDC floor fan is also a classic 2-in-1 solution of main control and motor drive. The motor drive adopts 2 shunt FOC for optimal silence effect. A flux linkage observer is used to estimate the rotor position, and an advanced startup strategy is used to achieve extremely low speed startup. The solution has on-fly and off-fly startup, deadband compensation strategy, and complete protection mechanisms. The main control includes Wi-Fi control, oscillating control, as well as human-machine interface including keys and LEDs. Handheld vacuum cleaners have become a must-have in every household. This BLDC handheld vacuum cleaner uses an HT32F65532G MCU, which includes a gate driver. It is supplied in the industry's smallest package for NN gate driver and is cost competitive. The high level of integration allows for reduced PCBA peripheral components. The use of one shunt FOC sensorless inherits the previous advantages and adds a special function of air outlet blocked protection, which aims to avoid overtemperature when the motor runs at high speeds without airflow. Next, let's look at the presentation video of a 3 series lithium battery handheld vacuum cleaner. This is a lightweight 3S Li battery handheld vacuum cleaner suitable for car and household vacuuming. Its control core is motor vacuuming and Li battery charge-discharge management. The motor driving is achieved using a Holtek's new high-integration SoC BLDC MCU, the HT32F65532G. This 32QFN small package device includes an MCU, an LDO, a 48-volt NN gate driver and a bootstrap diode, which allows for simplified motor control PCBAs requiring only a few passive components. A cost-competitive one-shunt FOC sensorless architecture is used for motor driving, requiring no rotor position sensor but only one current sampling resistor. The motor is started in an adaptive open-loop control manner, with small vibrations, low noise and high-speed startup within 100 milliseconds. To ensure the product safety, Holtek provides complete over-under voltage, over-under speed, over-current protection mechanisms for motor operation. When the air outlet is blocked, the motor will be stopped immediately to avoid control board and motor overheating. The product provides 2-gear torque control. The first gear of motor speed produces a smaller suction and a lower power consumption. The second gear of motor speed produces a larger suction and a higher power consumption. When the vacuum cleaner is stopped, the motor will first decelerate to a weaker suction and then be stopped by a fast and high braking force to avoid dust leakage. This is the Holtek's complete vacuum cleaner solution. Electric vehicles are a very hot product at present. This is a one-shunt FOC Hall solution implemented by the HT32F65232. Like most electric vehicles, it adopts torque control, with Hall even compensation, voltage compensation, electric braking, over-modulation technique and Hall loss protection. In terms of peripherals, it can be connected with instruments and throttle handles to achieve torque control and display. In terms of driving safety, there are light signal control, braking and pedal sensing detection. This BLDC range hood uses one shunt FOC sensorless control implemented by the HT32F65232. The input PFC control ensures a high power factor and stable voltage. The adaptive positioning control can reduce blade jittering. Other features include constant power and constant airflow control, voltage compensation strategy as well as basic protection to improve safety. The BLDC control communicates with the main control and human-machine interface through the UART. The main control and human-machine interface are designed on the light board, with functions of display, air quality sensing, Wi-Fi and touch keys. Holtek also provides a series of touch key MCUs. Customers can consult through Holtek website or best modules. This electric impact wrench is implemented by a highly integrated MCU, the HT32F65532G, which includes a 48-volt gate driver and an LDO. The square-wave sensorless solution uses IPD technique for startup, resulting in no vibration, which combined with the MCU's integrated back EMF filter achieves low-speed stability and fast startup. Other features include backward self-stop, constant power control, battery module communication and complete protection mechanisms. Through the above sharing, you have learned that Holtek's HT32 BLDC motor MCUs provide very reliable techniques and solutions, either in FOC or square-wave control. In the solutions, there are many motor peripheral functions that require the use of ICs, and Holtek can also provide high-quality services comparable to motor control. Holtek's BLDC motor MCUs have a variety of advantages. 1. complete product specifications including pure MCUs, and highly integrated system-on-chip MCUs with an internal gate driver or driver. 2. Low cost, stable delivery, and excellent services. 3. Full range of HT32 application examples, complete development and programming tools. 4. Motor platform with a high-quality and friendly interface, enabling customers to greatly shorten the development time period of motor drive. Finally, we thank you for listening. Please contact Holtek and Best Modules if you have any IC needs.